For this tutorial, I'm going to teach you how to create dynamic cards and tabs in C# Windows Forms. We'll build an interactive interface where clicking on a card automatically adds a corresponding tab, and selecting a tab dynamically updates the card list. For this tutorial, I will be using C# with Windows Forms in the .NET framework. I have added two flow layout panels to my form. The reason I'm using flow layout panels is because they're great for handling dynamic controls. They automatically arrange everything, so I don't need to position each control manually. In this setup, one flow layout panel is going to act as the tab container, and the other will be the card container. Now, you don't have to copy my exact design. Feel free to style your form however you like, but if you want to follow along step by step, you can use the same layout I'm using here. Now let's move on to creating our card control. To do this, right-click on your project, choose Add, and then select User Control. I'll name this user control simply Card. Once the control is created, you can add any child controls you need inside it. For this tutorial, I'll be adding a picture box to display an icon and a label to show the text or title of the card. Feel free to customize your card design however you like. Add more controls if needed, but for now, we'll keep it simple. Now let's start coding our card control. We'll write a few lines of code to make this user control reusable and clickable. This line declares a private string variable named text and gives it a default value of label. Think of this as the internal storage for our card's label or title. Here we create a public property called custom text. This allows us to get or set the value of the private text variable from other forms or classes. It's a clean way to make the card text customizable while keeping the internal variable encapsulated. Next, we define a public method named detail. This method simply assigns the provided string value to our custom text property. Later on, we can call this method whenever we want to update the text shown on a specific card, for example, when loading data dynamically. Inside the constructor, we first call initializeComponent to load the design of our user control. Then we attach a click event to the entire card. What this line does is say, whenever this card is clicked, trigger the card-clicked event. Don't forget to declare an event named card-clicked. This will be the event that other forms or components can subscribe to, for example, to perform an action when the user clicks on a card. Now let's make our card control a bit more interactive by adding two event handlers, mouse hover and mouse leave. These events will let us change how the card looks when the mouse moves over it or leaves it, which helps make the UI feel more dynamic. Now I've added a default tab in our main form. This tab will serve as a reset button that clears or resets the content inside our card container. For this, I'll simply use a label control as my tab. Later, we'll add a click event to this label so that whenever it's clicked, it will clear all the cards inside our container. Next, I'm going to declare three arrays: main, files, and documents. We'll be using the values from these arrays as the content for both our cards and our tabs. The main array will contain the first set of cards that load by default, for example, files and documents. Then when we click on a specific card like files, it will load the next set of cards from the files array, which might include videos, pictures, movies, and music. The same goes for documents, where we'll have items like source codes, projects, and bills. This setup makes our interface dynamic, meaning the content changes depending on which tab or card we click on. Let's create a new method called addCards. This method will handle displaying our cards inside the card container. It will take an array of strings as its parameter. These will be the text values shown on each card. Inside the method, we first clear all the existing controls from our card container. This makes sure that whenever we load new cards, the previous ones are removed, keeping the interface clean. Next, we loop through each item in the array using a for each loop. For every item, we create a new instance of our card control, then call the detail method to set the label text for that card. After that, we simply add the card to the card container, and once the loop is done, all the items from our array are now displayed as cards. So in short, this method dynamically generates and displays cards based on the array values we pass into it. Oops, it looks like the label text inside our card isn't showing up. Even though we're passing the values from the array into the detail method, the label inside our card control hasn't been connected to display that text yet. Let's fix that. Go back to our card control and add a paint event from the properties window. Inside this event, set the label's text equal to our custom text property. This ensures the label updates automatically whenever the card is drawn. Now, if you run the project again, the card labels should display the correct text from our array. Now let's move on and create our tab control. We'll build it the same way we did our card control earlier, by adding it dynamically and customizing its appearance. Inside our tab control, we'll add a few child controls to make it interactive and visually appealing. I've added 2 picture boxes and 1 label. The first picture box will be used for the icon, giving each tab a distinct visual identity. The second picture box serves as a close button, allowing users to remove a tab whenever they want. Finally, the label will display the tab's title, making it clear what content each tab represents. Of course, you're free to add more child controls if needed, maybe a hover indicator, a small progress bar, or even a drop-down menu for tab options. This approach keeps our tabs flexible, interactive, and easy to manage, while maintaining a clean and modern design. Let's add some interactivity to our tab control. We'll start by creating a public event called tab_clicked so we can detect when a tab is selected. Then we'll define a private string named tabName with a default value of tab, along with a public property custom tab to set or get the tab's name. For now, the property simply assigns the value to tabName, but later we'll use it to display the tab label or handle click actions. This makes our tab control ready for dynamic naming and interaction. Next, let's add a click event to the close button so that when it's clicked, the main form will be notified and can handle closing or removing the tab. This makes our tab control more dynamic and responsive to user interactions. Next, let's create a new method called detail. This method will work just like the one in our card control. Its purpose is to set or update the title of the tab whenever we pass a new value to it. For the next step, let's add a paint event to our tab control. This event will handle setting the label text of the tab, ensuring that the title displays correctly whenever the control is rendered or refreshed. Now, in our main form, let's create a method called addTab. This method is responsible for adding a new tab whenever a card is clicked. It first checks if a tab with the same name already exists to avoid duplicates. If not, it creates a new tab control, sets its title using the card's text, and adds it to the tab container. Finally, it also attaches the tab clicked event so the form can respond when the tab's close button is clicked. This setup ensures that each card generates a corresponding tab dynamically, keeping the interface organized. It also prevents duplicate tabs from appearing, which could confuse the user. By linking the tabs to the cards, we make navigation between content more intuitive and interactive. Inside the event handler, we first check if the sender is a tab. If it is, we remove that tab from the tab container and then dispose of it. This effectively deletes the tab from the interface whenever its close button is clicked, keeping the tab container clean and preventing unused tabs from lingering. Now, let's enhance the Add Cards method by adding a click event for each card. With this code, whenever a card is clicked, it will call the addTab method and add a corresponding tab to the tab container. This ensures that selecting a card dynamically creates or updates a tab, keeping the interface responsive and making it easy for users to navigate between cards and tabs. Let's add another event to our tab control called View tab. This will be a click event that triggers whenever we want to populate or refresh the dynamic card list based on the selected tab. To implement it, add a click event to the label inside the tab control and invoke the View tab event inside it. This way, whenever the user clicks the tab's title, the main form can respond and display the corresponding set of cards dynamically. Let's update the Add tab method in our main form. We'll attach the View tab clicked event to each newly added tab. Let's handle the View tab clicked event in our main form. Inside the event handler, we first check if the sender is a tab. If it is, we get the tab's name from its property. Then, depending on the tab's value, we call the Add Cards method with the corresponding array. For example, Files loads the Files array, and Documents loads the Documents array. This allows the main form to dynamically populate the card container based on the tab that was clicked, keeping the interface responsive and synchronized with the selected tab. Let's add a click event handler to our main tab. When this tab is clicked, it will reset the card container and load the files array by default. This provides a quick way to return to the main view and ensures that the card list is refreshed with the initial set of items. Now we successfully created this dynamic cards and tabs. Thank you for watching, and please leave a like, subscribe to my YouTube channel for more .NET Windows Form tutorial.